This video will provide an overview of the new features added to the battery setup tool in Primer version 22. The battery setup tool was introduced in Primer version 21 to expedite the creation of pouch battery cell models relying on EM-Randos keywords to simulate the internal electrochemical reactions. The tool provides guidance through the different stages of model creation, supports all four Randos modeling scales, and automates the creation of required keywords to model structural and electrical connections. The different stages of building a battery cell model through the tool involve selecting the desired Randos modeling scale, creating the layer structure, setting up the tab structure along with the required mechanical and electrical connections, defining the Randos properties, and activating or creating relative analysis keywords. In version 22, a new battery primer construct was introduced that references all created LS-DYNA entities and defined attributes. This enables creating, modifying, deleting, copying, orienting, and sketching multiple battery definitions within a model. The attributes of a battery definition are saved in the model keyword file after the star end card, allowing the restoration of battery setup definitions in future primer sessions. I'll highlight further improvements through a brief demonstration. In version 22, invoking the battery setup tool brings up a menu in the side toolbar with the options I've just mentioned. Let's create a new battery definition in Model 1 using the default values for the battery ID and title. We'll import data from a pre-saved CSV file to build a battery cell using the macro Randos scale. Next, we'll define the properties of the layers structure. In version 22, the multiple repetitions of unit cell option allows creating full replicas of unit cells in both X and Y directions, forming an array under the same battery definition. For example, to create a 3x2 battery cell, set the repetitions in the X direction to 3 and in the Y direction to 2, with appropriate separation distances. Since all other attributes are already defined, click Create to generate the LS-DYNA entities modeling the layer structure. This creates 6 parts modeling the composite unit cells of our battery. The tool now remains on the same panel, allowing review and modification of settings before proceeding. To modify layers properties, click Edit, make changes, for example, increase the number of repetitions in the Y direction, and click Create again. This editing capability also applies to steps 3 and 4. To move to the next step, select the corresponding button at the top or click Next. This panel defines the properties of the tab structure. Version 22 adds options to alternate tab polarities in X and/or Y directions and auto-create EM isopotential connect keywords for electrical connections between unit cells. The latter can be done based on a range of possible configurations, depending on the selected tab's positions and relative polarities. When multiple variations of a given configuration are possible, for example, in this setup we have 4 possible variations of connecting all cells in series, a sketch differentiating these variations can be viewed by clicking on the accompanying Help button. Once we create the tab structure, the generated isopotential connections can be visualized by sketching them. For step 4, we'll use the imported data to create EM-Randos keywords, as no significant changes were made in version 22 for this panel. Similarly, for the final step, click Apply to activate and create the selected analysis keywords. At any stage of the process, you can move between steps using Previous and Next buttons, or tabs at the top to view or edit settings. Clicking Create Battery in the last step closes the setup window and generates the battery definition referencing all created entities. Other improvements include changing the default orientation of the created battery cell to something more sensible, adding the option to turn off the auto-creation of EMMAT cards, improving file selection when importing data from CSV, and adding the drawing, sketching, and picking capabilities for the EM isopotential and EM isopotential connect keywords. Thank you.